Khushbu with LitePoint. Today I am going to share an overview and a brief demonstration of LitePoint's mmWave RF test system. The system contains three primary elements: the IQgig 5G RF test system, the mmWave RF test chamber, and AMAS, our antenna measurement and analysis software. The IQgig 5G has an RF source and analyzer that operates from 23 to 45 GHz. This test equipment generates waveforms and analyzes signals that follow 3GPP 5GNR standards. It has a single VSA and VSG and 4 bidirectional RF ports. For our demonstration, the IQgig 5G is connected to the mmWave chamber with one port providing an RF signal source and 2 ports used to measure the horizontal and vertical polarization of the transmitted signal. To demonstrate both the source and analyzer, today we will test a simple patch antenna typical of those used with mmWave devices. The mmWave chamber is designed to operate from 23 to 45 GHz. It contains a positioner at the bottom to hold the dot and can automatically rotate the device to any orientation for antenna pattern measurements. At the top of the chamber is a dual polarization measurement horn that is used to measure the signal which is transmitted from the DOT. For our demonstration, we will use AMAS, LitePoint's antenna measurement and analysis software. This software performs automated chamber calibration to determine the RF path losses, and it adjusts the positioner and performs automated 3D RF measurements. Once the data is collected, AMAS analyzes and plots the measurements results. Let's take a peek at the system in action. On this screen, we define the frequencies and RF paths that will be used for calibration of the chamber path losses. To perform these measurements, either the IQgig 5G or an external RF power meter can be used. Here we set up the parameters to perform RF measurements of our patch antenna. We define the frequencies which will be used, and we define the three-dimensional coordinates that will be used. And then we start the measurement. Here we see the positioner adjust the device to a variety of angles. At each position, horizontal and vertical polarized RF measurements are being performed at the frequencies we specified in AMAS. During the measurement, the results are plotted so you can see real-time measurement data. After the data is collected, we use these analysis functions to analyze and view the data. Here we see a two-dimensional planar plot. Here we see a two-dimensional polar plot with peak values and 3 dB bandwidth shown on the display. And finally, we see a three-dimensional plot of our measurement data. This plot can be rotated and scaled for a more accurate visualization of the antenna pattern. IQgig 5G is a fully integrated multi-band mmWave non-signaling test solution, and it's the first of its kind to support all 5G frequencies within a 23 to 45 GHz range. For more information, please visit us at litepoint.com. Thank you.